Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3352. Subject name Foundations of Data Science. Unit 4 Python Libraries for Data Wrangling. The topics presented here are comparison operators, Boolean operators, masking operation, fancy indexing. First, comparison operators. NumPy also implements comparison operators such as less than, greater than, as element-wise functions. The result of these comparison operators is always an array with a Boolean data type, either true or false. Here are the list of comparison operator. Double equal to specifies np dot equal of. Exclamatory and equal to symbol indicates np dot not equal of. Left angular bracket represents np dot less than of. Left angular bracket equal to symbol indicates np dot less than equal to. Right angular bracket specifies np dot greater of. Right angular bracket equal to symbol indicates np dot greater than or equal to. Here is an example. Here X array consists of values 1, 2, 3. In the first line, we have written x less than 2. This operation is performed element-wise on the given array. So, first value in the array is 1. 1 is less than 2. So, it produces true. Next value is 2. 2 is less than 2. So, it is false. Next value is 3. 3 less than 2. It is false. For example, in the next example, x greater than 2. That is, it produces a result as false, false, true. In the next example, we have checked x not equal to 2. So, the first output is true, the second value is false, and third value is true. And in the fourth statement, we checked x is equal to 2. So, the output is false, true, false. The list of Boolean operators is shown in this table. Ampersand symbol specifies np dot bitwise and. Pipe symbol indicates np dot bitwise r. Exclamation symbol exponential symbol indicates np dot bitwise xr. Tilde symbol indicates np dot bitwise not. Masking operation. A more powerful pattern is to use Boolean arrays as masks to select particular subsets of the data themselves. For example, let us consider X array with values 5033, 7935, 2476. For the statement x less than 5, we get the output like this: false, true, 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 false, false, true, false, true, true, false, false. This is the normal output. To select these values from the array, we can simply index on this Boolean array. It is known as a masking operation. That is, we can write as x of x less than 5. So, it produces the values of the result true. That is 0, 3, 3, 3, 2, 4. The result is a one-dimensional array filled with all values that meet this condition. In other words, it can be interpreted as all the values in positions at which the mask array is true. Fancy indexing. Passing an array of indices to access multiple array elements at once is called fancy indexing. Fancy indexing can be applied in indexing or accessing more values, array of indices, in multidimensional arrays, and in standard indexing. Example, Here is an example. X array consists of values 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Fancy indexing can be implemented as follows. That is x of 3, x of 6, x of 9. Only the elements in the positions 3, 6 and 9 will be printed. That is the values are 14 in the third position, 17 in the sixth position and 20 in the ninth position. So 14, 17, 20 are printed. We can also modify the value with fancy indexing. Here we take the same X array, that is the values from 7 to 20. In the next line we have written I is equal to np dot array of 2, 1, 7. That means I of 2, I of 1 and I of 7. So in the next line we have written x of I is equal to 100, and in the next statement we have written print of x. So now the ith position will be changed to 100 from their original values. Now see here x of 0 is 11 and x of 1, it is represented as I value. So it is replaced. The 12 is replaced as 100. And in the second position the value 13 is replaced as 100. For all the other positions from 3 to 6 the values are printed, and for the seventh position the value is replaced as 100, and for 8th and ninth position the same values are printed. And next one is, for example, x of I plus equal to 10. That statement is equal to x of I is equal to x of I plus 10. So the value in the ith position will be added to 10 and the result will be printed on the screen. Print x. This statement produces 11, 110, 110 and then 14, 15, 16, 17 and then 110 and then 19, 20 will be printed. Thank you.